to the Create for STEM Brown Bag series. It's my pleasure to announce my friend and colleague, Leema Berland, who's going to be talking about her work today. Leema comes to us having finished her PhD in learning sciences from Northwestern and has a fascinating background also with a computer science undergrad degree, so she brings some really interesting perspectives on that. She was a professor for a while at UT Austin and is now a faculty member at Wisconsin doing lots of interesting things there. She is a PI for an NSF grant where she is working with teacher candidates, right, around argumentation, trying to help them engage their own students in argumentation and finding some interesting things about that. She is co-PI for a project on scientific practices at the elementary and middle school level and has been studying for quite a while the nature of argumentation, but as well she looks at explanation and modeling in some of our recent work that we've been doing. She is particularly interested and has done some very careful work looking at how students participate in the discourses of scientific practices, so looking at dialogue in the classroom and how that can be fostered or inhibited and how students interpret what they're doing and perhaps why. And so she's going to be telling us a lot more about that in some really interesting ways. A couple more announcements to tell you. This is being video recorded. I guess I'm supposed to let you know in case you want to refrain from saying anything problematic at the end of the talk. And then also I want to tell you about a few announcements of upcoming seminar presentations. The next one is going to be on the 19th of November on scientific modeling, and Danny Caballero and Tammy Long and I are going to be talking about the research that we're each doing in scientific modeling at different grade levels and in different subject areas. On the 21st, there's going to be a math seminar series speaker, or set of speakers, Jean Wald, Tina Gerhardt, Benjamin Schmidt, on the challenges and opportunities of teaching undergrad mathematics. And then a work in progress, December 3rd, by Sonia Underwood. So those are coming up. And let's go to Leema's talk.
Well, thank you, Christina, and thank you all for having me and coming out this afternoon. It's one of your last beautiful sunny days, it looks like.
Yeah.
Mine too, coming from Wisconsin. I'm not denigrating. I've had a lovely morning talking to you guys. Really interesting conversations and thinking about some interesting challenges, and I'm looking forward to the rest of my time here. I'm going to be talking to you about some work I've been doing looking at student engagement in the scientific and actually a little bit in the engineering practices, and thinking about whether or not it's meaningful and what that word meaningful means and why I care about it. So that's what we're going to talk about today. Remote control, backwards in my hand. Okay, so Christina already went through all of this. I will just say that I've been doing work on a number of NSF projects looking at student engagement in a bunch of projects in a bunch of different ways, and so that's all. So this is me. This is what I think about. This is my day-to-day life. So we're going to talk today about why I care about meaningfulness, and I'm going to start with kind of a theoretical perspective about this word practices, and I would argue that it requires us to think about whether or not it's meaningful for the students. And then for the second half of the talk, we're going to, hopefully by then I will have convinced you that it matters. And so then we're going to talk to you about whether or not what factors influence that, so we can start to think about how to foster students' meaningful engagement once we care about that. So first, this word practices and how does it relate to meaningfulness? So, over the years we've seen the goals of science education in K-12 shifting a little bit, shifting from a focus on content that we want to be thinking about the facts of science and students learning that, to thinking more about the processes of science. The scientific method would fall under this. Control of variables is a really big deal in a lot of people's work. To now the scientific practices. And this focus on the scientific practices has been reified by the NRC syntheses of research, as well as now in the NGSS, in the next generation science standards. And so it begs the question, I think, what are the practices? What does the shift in language mean? Why are we saying practice now instead of process? What are we actually buying there with that shift? So I define practices as a set of sensible actions, and by sensible I mean that that the actions that you're doing fit together, they're coherent, they fit together as a meaningful piece of work that you're doing, and they're useful. They fit together because they're helping you accomplish a particular goal. So the practices are a set of sensible actions that are constrained by the socio-material context. Socio-material is a really big word that really just means social and material. So it's really complicated. So by the social context, we're thinking about the expectations. What's appropriate right now? What is expected of me? How are we supposed to be interacting? Why are we doing these things? By the material context, we really mean what resources are available right now. What's the setup of the room? Right now, you guys are all facing me. That is a material constraint on how we're going to interact, right? And so the practices, when we say the word practice, we mean a set of sensible actions that are constrained by that context. What this actually means when it plays out in the classroom, and this is a quote from a paper that I worked on with Christina and others, is that when we engage in the scientific practices, that requires that the student work in the practices are part of an ensemble of activity that fits together as a purposeful endeavor. So what the students are doing needs to feel purposeful to them. It needs to be meaningful. They need to see the connection between this particular action and how it's going to help them accomplish the goals, the broader sense-making goals. So that's the word practice. The word science has other implications. It means that we care about what kinds of questions the kids are investigating, and we care about the epistemological understandings, their approach to answering those questions. These things are really important. I grade them out, not because they're not important, but because I'm going to focus today on the purposefulness or the meaningfulness of the ways that they're doing that engagement. Okay, so hopefully I've started to construct an argument for you guys that it's really important for us to think about the meaningfulness, that the word practice really requires it, that if we want students engaged in the practices of science, then we want them to understand what they're doing and why they're doing it. I also have some empirical work that argues and shows that students are going to adapt the practices to make them meaningful. So the practices perspective tells us that everything we do, we're figuring out how to make it meaningful. And so if we take a practice from the science field and we say, let's do it in the classroom, the kids are going to change it. They're going to make it work in their classroom context. They're going to make it meaningful in their classroom context. So if we're not paying attention to the meaningfulness, well, they're going to do something that's probably not what we want. So we need to be thinking about that. So I'm going to show you that now. This actually comes from my dissertation. So those of you who are students, you'll be able to write your dissertation for years. So we're looking at scientific argumentation, how classroom communities adapt scientific argumentation to make it meaningful. A little bit about argumentation. Scientific argumentation is a complex discourse practice that involves two goals relating to each other. So one goal is sense-making. You're trying to make sense of something. The other goal is arguing or persuading, trying to convince other people of your understandings. And it's through the interplay of these two goals that the scientific community ends up making sense of the thing under study. It's through this collaborative sense-making that we really come to understand, and we can't do it individually. So when you engage in scientific argumentation, you're really engaging in the goals of persuasion and sense-making, and both of these pieces are important. What that actually ends up looking like is a bunch of discourse moves, or if you think about my definition of a practice, a bunch of actions. So when you engage in scientific argumentation, you're questioning. You're saying, hey, why do you think what you think? I think this other thing. You're evaluating. You're saying, I think this other thing, and possibly challenging, right? You're making claims. You're defending your ideas, and you have to be attending to one another. Also, if you're going to engage in the collaborative piece of this, you're going to be revising. You're going to be paying attention to what other people have to say and thinking, oh yeah, that evidence, maybe my claim needs a little bit of tweaking so that I can account for this other thing in the world that you saw that I didn't see. So scientific argumentation involves all of these discourse moves. If you remember my definition of a practice, this is kind of the set of sensible actions, and they're made sensible by the goal of collaborative sense-making. The other half of that definition was the socio-material context. So I also like this representation of argumentation, that the goal of argumentation is still that collaborative sense-making through persuasion. But here we see that the different actions are constrained by the outer frame. They're constrained by the socio-material context. That those pieces of argumentation fit together as this puzzle to help you work towards collaborative sense-making because of the socio-material context, because of the fact that we're in a community that expects us to behave in these ways and to interact in these ways. So the question becomes, if we take this practice and we take all of these discourse moves and we move them to another context, what's going to happen? Are the kids going to engage in all of those discourse moves? Are they still going to make sense in a classroom community that has a completely different set of epistemological and behavioral expectations? And so that's what a lot of my work thinks about. That's what I'm going to talk to you a little bit about. We're going to talk about this in the context of 6th and 7th graders who are arguing about a net logo simulation of a miniature ecosystem. The ecosystem contains foxes, rabbits, and grass. We don't really need to understand the details to understand their conversation, but I'll tell you really quickly. Over here in the graph, foxes, rabbits, and grass are in a cyclical relationship that's pretty stable. There's a lot of fluctuation, but that's because, as the foxes increase, it causes the rabbits to die out because they have more people eating them. But as the rabbits die out, foxes are going to die out because they have less food. And so there's a lot of fluctuation, but it's stable. They're all able to survive. Then the kids introduce an unknown organism, the invasive species, and that's the black line here. And it's their job to figure out where the invader fits in the ecosystem, so what eats it and who it eats. And so they work in pairs, they work in small groups, and they work in a whole class argument around this question of where the invasive species fits in the ecosystem. And they're analyzing complex data like this in each of those different settings. So I'm going to show you some video of classes in the whole class point of that as they make sense of this. So we're going to look at this video. This is Mr. S's class. My analysis is really looking at the discourse moves. Are they making justifications? Are they making claims? Are they questioning one another? Not the content of, did they say this piece? Did they point to this piece of evidence? So here, as you watch this video, really just pay attention to the dynamics. How are they engaging in this argument? I don't have a mouse.
Because it already ate the rabbits.
If you say no, if you say
the rabbits, it would have died out.
If the rabbits are at zero, then how is the invasive species still surviving?
Because he noticed the rabbits.
Maybe grass.
He probably might eat foxes, but grass. See, look, always straight across. You see how I keep going like that, right? So it come up. Still the same, still the same, still the same. So it probably eat rabbits and foxes.
Okay, so that's Mr. S's class. If you guys want details about how I coded it, I'd be happy to talk about that during the Q&A, but right now I'm going to jump to my findings. So I analyzed it for those particular discourse moves that I've been talking about for argumentation. And I found that this class, over the course of their 30-minute argument, their 30-minute argument looked a lot like that. Over the course of that, they were making claims. They all had ideas about what the invader ate. They were defending their claims. You saw Tyler doing that when he pointed to the graph and said, well, look at what the line is doing. And they did that a lot. It was great. They also attended to each other's ideas. You think that? Well, I think this other thing, so let me try to poke a hole, right? And they worked on that really hard. And poking a hole, that's really hard work, right? And so they were really paying attention to each other's work. And they were evaluating. You see a lot of that at the end of this clip when the student says, Tyler, you ain't got nothing. That's a very evaluative statement, right? It's not the most respectful statement, but it is very evaluative. And they did that a lot. And so as I analyzed this 30-minute discussion, I tried to figure out what they were doing, because it certainly didn't look like the collegial argumentation that we like to talk about, right? And what I figured out is that their goal here was to win the debate. They were really focused on the persuasive aspect of argumentation here, right? They really wanted to win. And if that's your goal, then what they did makes perfect sense. If your goal is to win the debate, why would you ever revise your claim? Why would you ever say, oh yeah, that's a good idea, right? No. You're just going to keep pushing your own agenda. Similarly, you wouldn't ask open-minded questions to try to give someone else the floor and the opportunity because you just want to continue pushing your own agenda and persuading. And so what they did is a sensible set of actions to accomplish their goal. It's a practice that just doesn't look like what we had hoped to see. So they had adapted it in a way that was meaningful for them. I also did some post-interviews to kind of validate this interpretation, and invariably the kids said things like, well, we tried to prove that ours was right and theirs was wrong, right? So very persuasive, very focused on the competitive aspects of argumentation. I have another class that I'd like to show you, Miss B's class. What was that?
Looks like a faculty meeting to me.
Lovely. I'd like to show you this, but it's not going to work because I found out last night that there's no audio in this video, and I have no idea why. So I'm going to... Oh!
How did you know? How do you know?
Okay, well, there's audio. So let me introduce this to you. Computers. Okay, so this is a class of 7th graders engaged in the same conversation, but the teacher has set it up very differently. So these 2 students are presenting their final argument about what the invader eats. These 3 students on the side have been assigned the role of questioner, and they're supposed to be asking questions of the presenters. The rest of the class is off camera, and they are supposed to be observing. They rotated through the roles so that everyone got to do all of these things. 2 things that you need to know is that this group just argued that the invader eats grass, that it's a vegetarian, in their words. The other thing you need to know is that this group doesn't agree with them. The questioners do not agree.
That your invasive species is a vegetarian.
Because it only ate grass. The foxes didn't die at all. Only when the invasive species died.
And we made sure of that because we put the invasive species and the foxes in there alone with no randoms to make sure that that's what was going on.
Is there another way to look at this?
It could be another kind of animal, like another rodent, like a rat or a raccoon or something like that, but it does not eat foxes.
Okay, so it feels very different, right? It's not at all like the last video that I showed you. And I analyzed this class, and I found that, like Mr. S's class, they were making claims. Everyone got up there and said, I think the invader eats X. They were justifying their claims. They were pointing to the evidence. They were explaining why they thought that. They were attending to each other so that they could respond to the questions and ask the questions. And they were asking open-ended questions. They were saying, is there another way you could look at this? Now, the thing that's interesting is the girl that said, is there another way to look at this, asked that question because she had another way to look at it. She had a different claim. She had interpreted the data in a different way. But you don't know that, right? The kids never talk about that argument and that perspective, and instead they just exchange ideas and they engage in what I think of as kind of idea sharing. So they did this individual or small group sense making, and then they were doing idea sharing, and there was no persuasion. There was no need for them to engage in persuasion. And in fact, this class decided that they were all looking at slightly different computer models, and so they didn't have to compare ideas. They didn't have to persuade, because they all could be right in that world. And so this version of argumentation also made sense, right? It made sense in this classroom community. So again, we're seeing that they adapted the practice of argumentation to make it meaningful, to make it fit their way of approaching science. So these are the 3 different versions we've talked about argumentation. And we see this adaptation to make it meaningful. And another analysis that I did on these 2 classes, I looked at their work over the course of their enactment of the AQUIST unit, so 6 to 8 weeks. And I looked at the whole class discussions. And I found that Mr. S's class, the competitive class, that's kind of how they engaged in whole class discussions all the time. Not that animatedly. In fact, the teacher had usually a very strong presence. But they were always competing for the floor and kind of competing for the opportunity to show that they knew the answer. You would see them raise their hand, and when they weren't called on, they would just groan. And those sorts of things happened all over the place. And so it was a very kind of competitive orientation. I want a chance to show you that I'm right. And so that was consistent with their interpretation of the practice. Ms. B's class, it was a lot more individual sense making. It was a lot more the teacher knows the ideas, the kids are trying to figure them out. So the kids would ask her a question and they'd interact. and the kids would figure it out. But there was no peer-to-peer sense-making in that class. It was a lot of individual student-to-teacher interactions. And so again, that's consistent with their take on argumentation. And so we see that these adaptations are being influenced by the classroom context, by the socio-material context, by their expectations for how science class is going to work. So there are some implications. Sorry. One, from the perspective of argumentation, it's really hard to balance the goals of persuasion and sense-making. I've argued that these different interpretations of argumentation, they make sense, right? If you're really focused on persuasion, it might be really hard to switch goals and think about sense-making and all of a sudden give someone else the floor. Similarly, if you're really focused on figuring out, it might not always make sense to back up and start persuading someone. And so what I found is that it's really difficult to balance these goals. So it's important for us to recognize that when we say we want kids to engage in this kind of idealized practice, that's actually really hard. And I'm not saying we can't do it. I have some really nice examples of kids doing it, but we need to know it's hard, and we need to think about how to support this tension. We also see the point that I've been kind of hitting on throughout this is that the classroom communities will adapt the practice to make it fit within the context of their classroom community. And so we can't really expect this idealized form to just magically appear in what's happening in the classroom. We need to help them figure out how to make this form of it meaningful and purposeful and sensible in their classroom community. So hopefully I've convinced you that this is a thing that we need to worry about. So now we think about, well, then what do we do? How do we help them find the pieces of the practice that we really care about? How do we help them find those things meaningful so that they will do them in the ways that we hope to see? I'm not going to go through all of these different factors. I'm going to start with this one, epistemological and behavioral expectations. Those two things are related and they influence the student interpretation of the practices. This is a study that I did with David Hammer. It's a post hoc analysis of my dissertation data. Again, grad students, dissertations, cool. So this is a study that David and I did together. We were really inspired by Mr. S's class, and we focused on Mr. S's class. And in particular, we focused on the 10 minutes that happened immediately after that 30-minute argument that we just talked about. So this is a class that traditionally the teacher was in charge. It was a very teacher-driven classroom. And when we did that whole class argument that I told you, my co-researcher and I kind of sat on the teacher and were like, just let them go. Please, just let them go. Let's see what they do, right? And that was pretty difficult for the teacher. And then the bell was going to ring or whatever. They had to move on. And so it was time to wrap up. So he stood up and he said, the right answer is that the invader eats grass. And the kids had a really hard time accepting that. And so David and I were really curious about what happened in that conversation and what was going on. And so we studied it. And we looked at the behavioral and epistemic expectations that were happening in that conversation, because this disconnect between what the students thought they were doing and what the teacher said they were going to do made those expectations really explicit, because all of a sudden they weren't in agreement, and so they kind of had to deal with that. So I'm going to show you one more video of what happens when Mr. S tells us the answer. Nope. So one video that I didn't expect to work would help if I had a mouse. There we go.
In each class, Martin asked him, oh, how are you going to tell me no? Get it
Explain the foxes and the invasive species. The fox eats the rabbit. The only reason the fox is going down because if the rabbit's dead, it's not enough food for the fox to eat. My woman shut up when the rabbit's dead. That's why I kept saying Is the all still right that eats all foxes? Be quiet! Y'all taking his gun!
Okay. So as teachers and former teachers and teacher educators, you might be a little uncomfortable with what's happening up here. It's pretty chaotic. There's a lot of emotions. What was that?
Is this all boys?
No, it's not. It looks like it. Yeah, but it's not. Yeah, so it was a difficult moment. when we take a step back away from the immediate reaction to this, I actually find it really exciting. What's happening here is that for 30 minutes, the kids had all the epistemic agency. The kids were working really hard to figure out what was happening. They were engaged with each other. They were engaged in some form of collaborative something, not quite sense-making, we decided, right? But they were really working hard with the data, and the data was being held king in that conversation. They were trying to make sense of the data and convince each other using the data. And then the teacher stepped in, and he said, all right, I'm the teacher. I got the curriculum right here, and the curriculum tells me that it eats grass. And the students said, no, you can't do that. What about the data? Which is awesome, right? It's really cool that they were that engaged and that invested that they've pushed back against the teacher. And so I'm going to show you just a little bit of how we analyzed this discussion and how we made sense of it. So we were looking again at the epistemological and behavioral expectations and how they were made clear. It's a fun transcript. And how they were made clear by what they were saying. So Mr. S says, how are you going to tell me no? Yeah, it does. And so that has clear epistemic import, right? He's saying, I'm the teacher, I'm the authority, how can you tell me no? He literally had the curriculum materials open in his hand, right? And so he's saying, this is where the information comes from. You can't question that. At the same time, he's starting to get frustrated with the calling out of his students. And so he's got this undertone that he should be identifying the speakers, right? That's his typical role, and he was pretty uncomfortable with what was happening here. Alternatively, the students, they seem to think that they should be able to manage the speaker, right? They're calling out. They're not waiting to be called on. They're used to waiting to be called on. They know how to play that game, but they weren't going to play the game in the moment. They thought they should have control because they'd had control for the last 30 minutes. When they did this, they were also using evidence to validate ideas, right? They were saying, well, but that doesn't explain this point on the graph. Look at the graph. You can't be the external authority telling me the answer. Look at the graph. And so what David and I found was that these things co-occurred a lot. That there was a lot of times that the teacher being the behavioral authority was linked with the teacher being the epistemic authority. And when the students were the behavioral authority, that was linked with an expectation that the ideas would come from the evidence, would be validated by the evidence. So that's what this slide is going to tell you. Interestingly, we saw it fluctuating. So both the students and the teacher would communicate both expectations at different points in this 10-minute conversation that happened. So the teacher authority, we saw this. How are you going to tell me no, right? We also see things like when the teacher first says the answer, one of the students says, we win. So clearly accepting the teacher's authority. At that point, it was a little self-serving, but he was still accepting the teacher's authority, right? Behavioral authority, there are times when the students were waiting to be called on, or at the end you heard that kid calling out, you're taking his time, and that's what kind of shut it all down. He was calling on students, he was frustrated when they were calling out. So those were the indicators of that. And we saw these things happening together a lot in this conversation. In terms of the alternative, sometimes ideas were constructed and validated using evidence, and we saw that when students said, well, that doesn't explain this evidence. Or at some points, the teacher would, instead of saying, well, yes, it does, he would say, well, let me walk you through this evidentiary chain. So then he was turning to the evidence rather than the curriculum in those moments. And similarly with behavioral authority, sometimes the students would call out answers without being called on, and sometimes the teacher would stop and give the students more time. He would say, oh, you're confused, you don't believe me. Let's talk about where you are rather than my agenda, which is very different than saying, how are you going to tell me no, let's move on, right? And so in those instances, he was letting the student kind of control the topic of conversation. And again, we saw these things as paired. And what this tells me is that typical behavioral expectations of the teacher being in control might be in conflict with the epistemic expectations that we need for the scientific practices. So the scientific practices really require that students engage in sense-making themselves, that they are the constructors of the knowledge, that they have the right to do that idea validation and to work with each other to figure things out, that it doesn't have to come from an external authority. But it might be really hard for kids to engage in that kind of work when the teacher is telling them when they can speak and what questions they should be answering right now. And so this study is pointing at this possibility and a thing for us to think about more. So that's one potential factor that could influence how students are interpreting the scientific practices. If we want to phrase it in this meaningful language, I'm suggesting that when the behavioral expectations are traditional, the epistemic work might not be meaningful for the students. It doesn't make sense to them when their teacher's in control of the conversation. I want to conclude this by thinking about the sense of utility. For this work, I'm going to jump out of argumentation. I'm finally going to leave my dissertation for you and talk about engineering, actually, students engaged in engineering education. So for this, we are relating students' perceived understanding of the utility of, in this case, the math and science concepts, and how that's influencing how they're engaged in engineering design. So this is motivated by a trend in the literature to be thinking about STEM integration, to be giving students engineering problems, engineering design challenges, and teaching them math and science through those engineering design challenges. We're seeing this at university level. People in this room can speak to that better than I can. We're seeing it in K-12. We're seeing it in policy documents. We're seeing it in Project Lead the Way. It's increasing in its emphasis. Texas and Massachusetts both have standards on it, as well as in GSS, of course. But what we also know is that it's really hard. So there's a lot of work out there that's talking about learning by engaging in design. Learning by design might be one of them. And we know from it that it can work, but it's really hard to do. And from a practices perspective, I would argue that it's about how the students are understanding the utility of the math and the science. The math and the science might not feel like a meaningful thing for them to do right now. It might not be useful because they're really worried about designing an object. And so that's what this study is investigating. This study is actually in the context of in-service teachers who are certifying to become engineering teachers. This happened in Texas, and Texas actually introduced a fourth-year science program, so everyone can take science for 4 years, and fourth year is often engineering. But to do that, you need to be certified. You need to have some engineering teachers, and so that's what we were doing. So these are teachers of math and science who are learning to teach engineering, and it was a summer institute, and they were designing pinhole cameras for part of one of their class projects, so they were engaging in some engineering design themselves. We hoped that designing pinhole cameras would create a context for them to think about how light travels, right? So this is a picture that is in the curriculum materials. The light travels in straight lines. That's why the image is flipped in a pinhole camera. And it helps you think about ways to prevent light leaks and to aim the camera without letting the light touch your film paper before you're quite ready. So that's what we hoped they would be thinking about. To study this, we looked at transcripts of students as they engaged in the building and designing of the cameras. And we were looking explicitly at how they defended their design decisions. So they would say things like, well, I think we should do this with our camera for this reason. And the for this reason tells us what they were finding important and salient in the moment. And so that's what we were coding. And what we found is that there was a lot of different criteria that they used. But most of the time, they were doing things really related to the product they were creating. So about a quarter of the time, they were thinking about design requirements. They were thinking about, oh, well, I have to take a picture from 5 feet away, so that tells me this about where the film should be in the camera. Or practicality. I have to build it in a day, so we should use cardboard, not metal. User needs would be things like users aren't strong enough to hold it still for long enough, and so we should find some tripod-like system. Okay? So they were thinking about those 3 things 3/4 of the time. Their decisions were based on that criteria. The little salmon triangle is science. That was about 3% of the time. There was an explicit discussion of the science. The orange is the math, so a little bit more. I think it was about 5. So then I thought about, well, what are they doing when they do the science? What does that look like? So I'm going to give you an example of one of those 3% instances. And this is from one of the groups they're thinking about where to put the film in the camera. And she says, well, here, there's no light rays coming in right here. And she talks about this like she thinks it's going to be a dead zone. There's not going to be any light right here because it's coming in at an angle. So she's thinking, very clearly, she's thinking about the science. She's thinking about how the light is traveling in that pinhole camera. But that's all she does. So she she's doing what I started to think about it as kind of encapsulating it into a soundbite so that it could become a foothold that she could then move forward on. She doesn't say, I wonder if there really is a dead zone there. Let me get a flashlight and a pinhole and investigate this. That's not what she does. She instead uses it as a foothold to move forward off of and talks about it very briefly. And that makes sense. Her goal is to build a camera. Her goal is not to think about how light travels. So this was enough for her to fulfill her goal. But this is what we saw when they were basing their decisions on the science. What were they doing the rest of the time? I want to show you a quick example of where we thought they could have used science, but didn't, okay? So this is an example. They were talking about how to aim the camera without getting light on the film paper, right? So you can't look through the camera because that gets the light on the film paper. So they thought maybe they'd tape a straw on top of their camera and use that as a viewfinder. But Sarah is worried. She says, well, she's worried about the distance from the straw to the pinhole, that would be inaccurate for the aiming, right? So Tina says, well, could we put it at an angle? And on the video, you see her gesturing like this, and so I actually think she means bending the straw in that little stair step. She also might mean an angle like that. Neither of these options would work, right? The stair step, you would see the back of the straw. The angle, you'd see the floor. Neither of those would you actually see what the camera was seeing. I want to remind you that Sarah and Tina are teachers of science. Sarah and Tina know, just like all of you know, that those options wouldn't work, right? I have no doubt of their understanding of how light travels and what would actually happen in these instances. But they're thinking about their camera. It's like they're spitballing, right? It's just a brainstorm, and that's fair, that makes sense. And they go from this, they say, well, the straw's not gonna work. That was the end of it. And they go from this and they design a really great mechanism where the film is on top of the camera, kind of up against the roof of it. They open the viewfinder, they aim, they drop the film, open it again, take their picture. It works great. But at no point do they investigate the science, right? Instead, they build their camera. And that's what they should have done, because that's what their goal was. So what I'm arguing is that they weren't exploring the concepts in depth when they don't have to, when they can successfully build their camera without doing that. So the science wasn't useful for their current goal of building the camera. What this tells us, oh, right. So the science wasn't useful for their current goal, right? So what this tells us is that if we want them to be investigated in the science, we probably need to be thinking about whether or not the science is necessary for what they're doing. So this was a hypothesis. It was a small study. It was 2 case studies, right? So I'm going to show you some quantitative work that followed it. Clearly, I'm a qualitative researcher, so please be nice to me. I worked with, yeah?
I'm just a little bit confused on why the science wasn't useful. It's because they had plenty of time for trial and error?
I guess. Or because they didn't think about it that way. They didn't frame it in their head as, if I do the science, it will reduce trial and error. That was not part of the way they were framing the task. And so I think that that's a really good question, and it's one of the ways that we think about fixing this is to make it really explicit. If you do this modeling work early, it's going to make your pictures turn out better faster, right? And that's something that we've done in revisions. So I'm going to put up some numbers. My co-author did the stats. That's what I have to say about that. So for this, we did a survey of 113 students in Central Texas who were all enacting this high school curriculum that came out of this research project. And we were building on the psychology theory, the expectancy value theory, which states that the students' perceptions of the value or the utility of, in this case, the math and the science, related to their expectancy for success, so their confidence in doing the math and science, should predict their effort towards engaging in the math and science. So we did this survey. And what we found out was that the value, their perception of whether or not math or science was useful, significantly and strongly predicted their self-reported effort towards doing math and science. So again, we're seeing that the perception of the utility was influencing how they were engaging in the engineering design practices. So kind of validating, hopefully, well, depending on which method you prefer, we're seeing it both qualitative and quantitatively. So from this, again, we're seeing that the student's sense of utility, is this valuable, is this going to help me accomplish my goal, is deeply connected to how they engage and how they interpret the work that we're asking them to do. So I've walked through some of my work looking at what it means to be meaningful and why that's important. One of the things that comes out of this work really strongly for me is that the students are going to adapt the practices, right? We say, do this scientific practice or do this engineering practice, and they're going to change it. They're going to make it meaningful for themselves, for their classroom community. They're going to make it fit, which raises the question, how do we support their productive adaptations of the scientific practices? If we know they're going to adapt it, how do we help them do it in ways that will still be consistent with our ultimate goal, that they're engaged in sense-making together? So right now, we're kind of saying, here's a professional practice. I'm going to try to make it really authentic for you. I'm going to try to make you little scientists. And I'm saying that doesn't really work because they have a completely different socio-material context, and we need to be paying attention to that. So instead, what we need to do is think about aligning the classroom goals with the goals of the practice. So for argumentation, what this means is we need to set up activity structures and social structures where the kids are really rewarded for engaging in the goals of persuasion and sense-making. So in some of my work, I engaged the kids in what I call argument jigsaw, where they're pairs of students figure out what they're doing, and then they come together and form a group of 4, and I purposefully make them groups of 4 that disagree with each other. And I say, okay, now you have to make one product. So you can't walk away, you can't agree to disagree. You have to make one product here. And that kind of forces the issue that they can't just engage in that idea sharing and walk away like we saw in the one class. Another thing we need to do is think about the epistemic agency of the students and really work on enabling that. Really put them in positions where we're valuing their ideas and their ability to make sense. This means that we need to be creating good contexts and trusting them to use those contexts. And we need to engage in responsive teaching using language from David Hammer, just checking the time, David Hammer and his group. It also, we hear David Stroop would talk about it as ambitious practices. In the math world, we talk about noticing and responding and interpreting to student ideas. All of these things, I think, are focused on the same thing, which is that we're trying to create a space for student ideas. We're trying to value student ideas and have the student ideas really influence instructional choices. So I'm going to end on my newest work, which Christina alluded to, with pre-service teachers. I'm doing this with Melissa Broughton and Rosemary Russ at Wisconsin. And we are trying to foster responsive teaching in our pre-service teachers, or at least foster the possibility that they might do it when they get to their classrooms. And we're doing this through pedagogical argumentation, which is a phrase we coined. Pedagogical argumentation is like scientific argumentation, but you're arguing about pedagogy, you're not arguing about the science. And so we watch videos, we look at student work, we find student ideas and we problematize them, and we make claims about student ideas and we justify those based on what we're seeing, and we interpret the student ideas. And then we connect it to a pedagogical decision. We say, if that's your student's idea, what do you think you should do next? And we're really explicit about that in our class discussions. So this can look like, in this case, the students, the pre-service teachers, I find pre-service research really hard. How many levels of students do you have? So the pre-service teachers in this quote comes from a time when they had a number of student ideas that they were looking at, and they're trying to figure out how they would sequence those ideas to have a cohesive conversation. So imagine that all the ideas are coming out of different groups, and now the teacher is going to have a whole class discussion with them. So what is she going to do? And we spent a long time interpreting the ideas, and then a student says, okay, well, I would start with Amy's idea because it could guide the conversation by leading to questions that lead to some of the other ideas. So to make that claim, you really need to understand what Amy's thinking, and you need to understand the relationship between Amy's idea and the classmates' ideas so that you can see the connection and how that ordering would work. So this is an example of kind of the pedagogical argumentation that we're hoping to be engendering in our classes. So that's me. Yes.
So I was struck as you were talking throughout that I was struck by what seems like a tacit role of metacognition throughout both student activities and teacher activities connected with, working with the practices and teachers making sense of it, and certainly the epistemic agency question is, what does it mean to do science, and what's my role here, either as a teacher or as a student. I wonder if you've thought about that connection, and if you would like to say anything about that. If so, I don't mean to suggest that you should, but I'm really curious if you've thought about it.
Yeah. I've thought about it more about the K-12 students than the teachers. I'm newer to the teacher stuff, so I haven't gotten there yet. But with the students, Christina and I talk about this a lot in our research group with the practices in elementary students, and we talk about what it means for the kids to be able to say, when you argue in science, you should have evidence, versus doing that, doing an argument and defending your claim with evidence. And we talk a lot about the difference in what we as researchers can say about those two different actions. When they do it, does it mean that they have any explicit knowledge about the importance of that in science? We don't know. And when they say it's really important in science, we don't actually know if it's something that they think is valuable in their classroom, right? They might know it's valuable for that scientific community, but does it have any bearing on what they're doing in a science class? And so, I think about it. Do you have answers?
We could mention the bootstrapping ideas.
Yeah.
There's some indications that metacognitive awareness might help students bootstrap to be able to do some of the practices more robustly, but that's not a given for all people in all cases, right?
So like, for example, poor experts and more expert-like novices, poor novices and expert-like novices. Is that what you're?
Right. So we're working with elementary and middle school kids. So if the teacher makes it explicit, for example, that the goal is to include evidence in their argument, their explanation, or their model, they are better able then to recognize that's the name of the game, but not necessarily.
But sometimes when the teacher does that, it can disrupt the meaningfulness of their work, right? So when a teacher says, use your evidence, then you'll have conversations with the kids where they're like, well, I only have 2 pieces of evidence, I have to find a 3rd one. And so they're no longer engaged in the science, right? They're doing more of a performance. And so that's something that we struggle a lot with.
So I guess this is, I think, related in the sense that I'm concerned about the relationship. You had a thing at the end about occasionally using direct instruction. And so the question is, what's the relation between direct instruction and epistemic authority?
Yeah.
And I'm thinking in particular of Mr. S's class, where the students are passionately defending an incorrect conclusion. And so my interpretation is that, that they're confronted with this very complex graph. And they don't really have an adequate set of intellectual tools to interpret that graph. And so they arrive at an incorrect interpretation and they passionately defend it. And it's nice to see the passion, but how are they going to acquire the tools that they need for a more defensible interpretation?
So in that case, there's a few things. One, other groups in that video did have the correct interpretation. And so in a class that was feeling a little less competitive, you might see the students doing that work for each other. And I'm sure we've all seen really lovely videos of students stepping in and saying, but I interpreted it this way, right? And helping each other make sense of that. So that's one answer. Another answer is that in this particular case, one of the things I love about it is no one here cares if we know that the invader eats grass, right? Like, that has no impact on anything. What matters is their ability to interpret the graph. Now, the student in the video wasn't doing a great job of interpreting the graph either, so that's a problem. But it's not a case where we really want to get, or really need to get to the right answer. We need to get to really rich, good data analysis, and that's our actual goal in that moment. And so that kind of frees us up a little bit to let the kids engage in it and not worry about the right answer at the end. The last thing is that when I think about the role of direct instruction, there's a place for it. There's clearly a place for it. It's about the timing, and it's about what you're saying. And so I recently had my method students doing a science talk, and and they did 2 different science talks where they were peer-led discussions about the science. And in one instance, the students, the teachers that were leading it would step in and say, they were talking about what happens when you chew gum, why the gum gets the consistency that it does. And the students in their conversation were really focused on the saliva, the interaction between the saliva and the gum. Saliva is all about it. Is it saliva or could water do it? And they were talking about that. And in fact, they got a little cup and put gum in a cup of water and tried to figure it out. And the student teachers really wanted them to be thinking about the chemical makeup of the gum and how that relates to the saliva. So they kept saying, what about the chemical makeup of the gum? What about the chemical makeup of the gum? And they read the ingredients on the gum label, and no one knows what those ingredients mean, and so it didn't push the conversation at all. And afterwards, we had this reflective conversation where we, with them, because remember, they're actually all adults in the room, and they complained. The students, the people who were acting as students, were like, you totally shut us down. We had no, and they didn't use this word, but we had no epistemic agency because we were going in this direction, and you kept pushing us in this direction. So we were talking about the balance of that like it's one thing for a teacher to step in and say, you're going in this direction, and I need you to be just a little bit over here. And that doesn't necessarily remove the epistemic agency. But what these people were doing was saying, you're going in this direction, and I need you over here, and it totally shut their students down. And so I think a lot about about what we're doing with the direct instruction, how close we are to where the students are.
I thought this was really interesting, and I love that you were thinking about context. When you were talking about kind of the epistemological setup of the classroom, I couldn't help but think about classroom goal structures, like performance-oriented, if it's really focused on competition. And that got me thinking about kind of the goals that individuals bring to a situation. So if I'm just a competitive student, and I'm in a classroom that isn't really focused on that competition, have you considered kind of the fit between the context or kind of the environment and the student or individual factors, and how much do you think those individual tendencies play into things?
Really good question. My work has mostly been at the community level, and I agree that there are definitely individual characteristics that influence that. The community is made up of individuals, and that plays into what's going to happen, right? I also think that individuals change in response to the context. So, I actually have a paper right now where I'm thinking about how the students, sometimes they talk about modeling in one way, and then you put them in a different context and they talk about it in a completely different way, right? And so, sometimes I question the stability of those characteristics, right? And so thinking about, just thinking about that, but I don't have an answer.
So, is Mr. S and Mrs. B, right?
Yes.
Okay. And Mr. S, the activities seem to be very spontaneous. Mrs. B, they were engaged in a role play. And so I wonder if this kind of argumentations in classroom, we want the students just to engage in argumentation without telling them we're doing this. So making them do it spontaneously. So do you have any first of all, was planned, they just knew they were going to do that, or it just happened? Mr. S just did the activity and the students happened to engage in that way. And if you compare, if that was the case, like you have 2 scenarios in which this happened, if there is any difference in the fact that the students know they are role playing, or they are actually, enthusiastically trying to defend an idea or argue about the evidences they have.
You guys have good questions. So in Mr. S's case, he introduced the discussion. I don't remember his exact words, but he said, you're going to persuade each other. Your goal right now is to figure out what the invader eats, and you're going to try to convince each other what you think. And they even talked a little bit about, when you convince each other, what do you think you're going to need? Oh, you're going to need evidence. Okay. And then you let them go. So that's how we set that up. Much less structured than what Ms. B did, obviously. I don't know what Ms. B's students would have done if she had given them just that level of instruction instead of doing the role playing. I don't know how they would have interpreted it. Given the existing classroom norms, I think that it would have still been more contained and less argumentative and less comparison across groups, just given what I know about their class and their history and how they interacted in general. But the other thing I would say is that activity setup and the difference between Miss B and Mr. S is part of the socio-material context, right? Like the students' actions were constrained by the activity structure, and that makes sense, and that's part of what I'm trying to emphasize there. So, yes. It's a good point. Yeah.
So I'm intrigued by your methods class, right, because I do methods here. And one of my favorite quotes about helping pre-service teachers recognize things comes from Paul Collins. He's a method, and he talks about, he wonders about how we can help pre-service teachers recognize points of departure from typical instruction. So when a kid, like in Mr. S's class, makes a claim about something, you could imagine that there's several ways to go that the teacher could do. So Mr. S made a decision about, well, here's how I'm going to treat what's happening in the class. But you also describe teachers who make a point of departure and do something entirely different. And so in your methods class, I'm hoping you can talk a little bit more about what kinds of scenarios do you give them to help them learn what should I pay attention to at all? Like when students say stuff, what are some key things that I should focus on? And then what do I do with those?
Yeah, sure. So one of the things we talk about in our methods class, and it's newer to the methods class than pedagogical argumentation, it's kind of emerged out of our attempts to do pedagogical argumentation, is there isn't a right answer. There isn't a, well, of course Amy should go first when you sequence these students, right? Sometimes maybe Laura should go first because I have a different goal, or because I understood Laura's idea differently than you did, or something, right? And so we talk, and we're starting to talk more and more about the trade-offs, which I think is consistent with the points of departure, that if we go with Amy, what do you think that's going to do for the students? And we talk a lot about how the students are going to, the K-12 students, are going to interpret that move. Are we making the space, are the teaching moves that we're making the space, what are they making the space for? Are they telling the students that your idea is valuable? Or are they telling the students that right now I want us to get to the right answer, which sometimes is what you have to do? Or are they telling the students that right now I really want you paying attention to each other, and when we're learning to do that, and that's important, so let's do that, like that's a valuable goal. And so we're asking them, and we're working really hard on being explicit about those goals. That was the warrant piece of that diagram, and the connection between our interpretation of what's happening and our pedagogical moves, and that's really all about our goal for what we're trying to accomplish. And so we talk about trade-offs. Does that answer your question?
Yeah.
Okay.
And connected with what David said, so your model primarily focuses on justifying the evidence, and you didn't really discuss how you value the contents, and how do you support pre-service teachers to understand the role of content when creating explanations?
Yes, that's a weakness of mine. And we talk about it a lot in our pre-service classes, and I'm working on some more codified approaches to it, so I don't have a good answer to you. But it goes back to what our goal is, and thinking about, when we talk about what is our goal in the moment, being clear about what is our learning goal, and helping think about the structure of the conversation to make progress towards that learning goal. But it's not, that piece is still very, very nascent in what we're doing.
Are we good? All right, if you have any more questions, feel free to talk to Leema afterwards. I have to thank Leema with our canonical Create for STEM month. Thank you note. Thanks for coming, Leema.
Thank you. You guys were a great audience with lovely, really thoughtful questions. I want to thank you.
Did you have announcements?
I think you covered most of them.
Okay, fabulous. All right, thank you. See you next time.